For example 3.2, we're looking at making use of a similar process to what we did in topic 1 and 2, this time finding the gradient, so how steep our curve is, of the tangent to the function y equals sine squared x at a given x coordinate of pi over 2. So when we're looking at the function of sine squared x, as it is written here, the squared goes before the x. My suggestion is to keep it that way, but alternatively you could also write the function of sine of x to the power of 2. So bringing that squared to the outside of the bracket. When we look at it in this form, it may be a bit easier to see that we're using again the chain rule. So the sine of x is our function inside the brackets to the power of 2. So when we want to derive that and find what dy on dx is equal to, we bring the 2 to the front and we keep sine of x as our function in the brackets, but then we multiply by the derivative of the brackets. So the derivative of sine is cosine. So our derivative or our slope function for the y equals sine x squared function would be 2 sine x cosine x. To then go ahead and finish the question and find how steep or what the gradient of that function is at a given point, we're going to make use of pi divided by 2 as our x coordinate. So we substitute that in. So the function at pi over 2 equals 2 sine of pi over 2 times by cosine of pi over 2. If we simplify that, f of pi on 2 is going to equal 2 lots of, so sine of pi on 2, imagining the sine curve, it's going to be at the maximum. So our maximum is at 1. Alternatively, the cosine of pi on 2, where we start at a maximum and we approach the principal axis, is going to be equal to 0. Anything multiplied by 0 is going to be 0. So our function at the point pi over 2 is going to equal 0. Because the slope equal to 0 means that at pi over 2, this given function of sine squared x is at either a maximum or a minimum, which we could confirm using our graphics calculator. But for now, that's all that this question's asked.